Okay, so let us see another example on how to draw the velocity diagram for some complex mechanisms. So as shown over here, we are having the mechanism in which OA is the crank. These are the links AB and AC. These are the oscillating links. CD is also the oscillating link. D is the slider and Q is the fixed point. So O and Q, these are the fixed point, and D is the slider which is sliding in this particular straight line path. The various dimensions of the links are also given over here. For example, OA is 150 mm, is OQ is 225 mm, QB is 200 mm, then AB is 250 mm, AC length is 450 mm, and CD is equal to 325 mm. So we can choose some suitable scale for the space diagram. Suppose we choose the scale of 1 cm is equal to 100 mm, and the crank is rotating in clockwise direction at 1000 rpm, and we have to find out what is the velocity of the slider D. But we'll find out not only the velocity of the slider D, which is sliding in this horizontal path, but we'll find out the velocities of all the other links and their corresponding angular velocities also. As we have seen in our earlier example, that velocity of the rotating link as well as oscillating link is perpendicular to the link and will be in the direction in which that particular link is rotating. So in this particular case, as A is rotating with respect to O and it is rotating in clockwise direction, so velocity of A with respect to O will be perpendicular to this link. Velocity of B with respect to A, neither B is fixed nor A is fixed, so we can say velocity of B with respect to A or A with respect to B will be perpendicular to this particular link. Similarly, B with respect to Q, because Q is the fixed one, will be perpendicular to this link. Similarly, velocity of either C with respect to D or D with respect to C. So velocity of D with respect to C will be perpendicular to this link because this is the oscillating link. Whereas slider, it is sliding in the horizontal path, so that velocity will be parallel to the path of sliding with respect to fixed point, that is either O or Q. So in this particular case, let us try to understand how this particular, if we rotate this crank in the given particular direction, then as you can see, this is a path traced by the slider. So in this way, this particular mechanism is working, and we have to find out the velocities of the various links in this particular case. Now, first step is always to find out the velocity of the crank, and we know that V is equal to R omega, where R is the link length. So link length we have taken in meter. So as we have seen earlier that 150 mm was the link, we have converted that 150 into meter by multiplying by 10 raised to minus 3, and omega is nothing but 2 pi n by 60, and value of n is 1000 rpm. So we can calculate this particular velocity as 15.707 meter per second. And now suppose this particular velocity vector we want to represent on our sketchbook by 5 centimeter. Then our velocity diagram scale will be 1 centimeter is equal to 15.707 divided by 5. The meaning of this particular thing is that on your sketchbook you are going to represent this vector by 5 centimeter. You can choose any value over here, say 6, 7, etc. Correspondingly, you will have this particular scale. So now, on your sketchbook, 1 centimeter is representing 3.141 meter per second. So, this is our velocity diagram scale. Now, as we have already seen, that we have chosen the scale, velocity diagram scale, as 1 centimeter is equal to 100 mm. So, using that particular scale, we have drawn this particular space diagram. So, this is 1.5 centimeter, this is 4.5 centimeter, and like that. And as we have already seen that the crank is rotating in the clockwise direction, so velocity of A with respect to O will be perpendicular to this and in the direction of rotation, that is clockwise. Velocity of B with respect to A will be perpendicular to the link, and it is shown over here, but whose magnitude and direction we don't know. Similarly, velocity of B with respect to Q is also perpendicular to this link. Velocity of D with respect to C is also perpendicular to this particular link, and velocity of the slider, it is sliding in the horizontal path as we have already seen. So it is D with respect to O or D with respect to Q. So it is sliding in this particular direction. So once again try to recall certain things. So velocity of A with respect to O is perpendicular and in the direction of rotation. Direction of rotation is clockwise, that is given in the example. So this is the first vector. B with respect to A, neither B is fixed nor A is fixed. So velocity of B with respect to A will be perpendicular to this oscillating link. Similarly, velocity of B with respect to Q. Now here Q is the fixed point, so it is compulsorily B with respect to Q, which will be perpendicular to this particular link. Similarly, velocity of D with respect to C will be perpendicular to this link because it is an oscillating link. And slider, it is sliding in the horizontal path. So D with respect to O or D with respect to Q, it is in this particular horizontal direction. Now what we have done, we have taken the fixed points O and Q at one point, and then one by one we start with this particular vector. So our first vector is A with respect to O. So draw a line parallel to this particular vector. So that we have drawn. Then B with respect to A. Out of this B and A point is known. So from A, draw a line parallel to this particular line. So that line we have drawn over here. From then the third vector is B, velocity of B with respect to Q. Out of this B and Q point is known. So from Q, draw a line parallel to this particular line. Okay. So these two lines, that is this particular line and this line, they will intersect each other at the common point, that is B. Then we have to locate this particular point C, which is nothing but the extension of this link AB. So we have taken the ratio over here. So AB divided by AC on your space diagram will be equal to AB divided by AC on the velocity diagram. So this link length, this particular length AB is 2.5 on the space diagram. Then this AC is 4.5. Whereas this AB, as you can see over here, is 1.52 centimeter. And we have to find out what is the length, what is the length AC over here. So if you calculate, then that value of AC comes out to be 2.736 centimeters. So from A, you have to locate the point C such that the length is 2.736 centimeters. So we'll get the point C over here. So as you can see, this is the point C at a distance of 2.736 centimeters from A. So as we have now obtained this point C over here, now we'll go to the next vector. So velocity of D with respect to C. So out of this D and C, C point is known to us. So from C, draw a line parallel to this particular line. So we have drawn a line parallel to this particular line, that is BDC, as shown over here. Then we'll go to the next vector, D with respect to O. Out of this D and O point is known. So from O, draw a line parallel to this line. Wherever these two lines they intersect each other, that is our common point of this intersection, that is D. Because VDC and VDO, the common point is D. So D is the point of intersection over here. And that will complete our velocity diagram. So as you can see now over. So once again try to recall these things. Velocity of A with respect to O will be, we have first drawn these 2 points O and Q, which are the fixed points. So from these fixed points O and Q, we have drawn a line parallel to this vector by 5 centimeter, because as per scale we are going to draw this vector by 5 centimeter. Then B with respect to A point is known. So we have drawn a line parallel to this particular line, so that we will get this particular line. Then B with respect to Q. So known point is Q. From Q, draw a line parallel to this line, so that both of them they will intersect each other at point B. Now, as far as the vector notations they are considered over here, we are finding out velocity of B. So arrow must be towards B. And over here also, as we are finding out velocity of B with respect to Q, arrow must be towards B. Then we have obtained this particular triangle O, A and B. Now we have to locate the point C, which is nothing but the extension of this A, B, C. Right? So extension of AB is AC, you can say. So by taking the proportion, ratio and proportion, so over here AB upon AC, okay, that is this particular AB upon AC ratio on the space diagram must be equal to AB divided by AC on the velocity diagram. So AB is known, that is 2.5. So this length is 2.5 centimeter by scale. AC length is 4.5 centimeter by space diagram scale. 1.52 that we have already obtained over here, and we have to find out the length AC, and that we have already obtained as 2.736 centimeter. So from A we have to continue up to point C. and such that the length is 2.736 centimeter. Now from point C, draw a line parallel to this vector. So VDC. So out of this D and C point is known. So from C, draw a line parallel to this vector. So that we have drawn over here. Then we'll come to the next vector, D with respect to O. Out of this D and O point is known. So from O, draw a line parallel to this line. So wherever these two vectors they intersect, that is our D point. So again you can see, as we are finding out velocity of D with respect to C, arrow is towards D. As we are finding out velocity of D with respect to O, arrow is towards D. And these are the various lengths that we have obtained. So we have to, if we want to find out the velocity, we have to multiply this length by the velocity scale. So that we'll see in the next part. So how to find out the velocity of these particular vectors. So velocity calculation. The first calculation, that is the required answer, is velocity of the slider. That is nothing but length OD in centimeter multiplied by velocity scale. So as we have already seen, the length OD is 3.36. So if we just go back, then you can see over here in this particular diagram, this is 3.36. That is the length that we have obtained. So just you have to multiply by this length to the velocity scale and you will get the respective velocities. So VDO, the length is 3.36, VDC, it is 1.32, VBA, it is 1.52 centimeter, and VBQ, it is 4.48 centimeter. So let us use this particular length to find out the velocity of various velocities. So velocity of the slider, as we have already seen, is 3.36, and velocity scale already we have seen that it is 3.14. So velocity of the slider is 10.55 meter per second. Similarly, velocity of the link AB will be equal to length AB in centimeter from the velocity diagram multiplied by the corresponding scale. Just now we have seen that length is 1.52. We can multiply this by the scale, so that we will get VB. And V is equal to R omega. So omega is equal to V upon R. So this velocity divided by the link length AB. We are calculating the angular velocity of AB. So, and please remember that this particular length AB is nothing but our original link length of the mechanism that is given in the example, which is in mm, that we have converted into meter. So the given particular angular velocity is 19.09 radian per second. Similarly, you can calculate the velocity of link BQ in the same fashion. So length BQ is 4.48 centimeter. You can calculate the omega also, that is V BQ divided by length BQ, original link length in meter from our data which is given in the example. So we can get this particular value. Similarly, you can find out what is the velocity of link CD by multiplying this particular 1.32, multiplication of 1.32, and velocity scale is 3.141, and the corresponding angular velocity also. So in this way, we can calculate the various velocities and angular velocity and velocity of the slider of the mechanism. Now let us see if the positions are changed, correct? For example, if we rotate this particular crank in some different, through some different angle, then see how the nature of the velocity diagram is changing over here. This is just for the illustration purpose that we have shown over here. So if you rotate this, then you will get the different shape of this particular velocity diagram. So in this way, you can calculate the velocities of the mechanism.